Now we are going to learn about second derivative. We have learned about the first derivative. This is a function. F of x is equal to x cubed minus 6x squared minus 36x plus 216 is some function. So this is a cubic function in third degree. Now I am going to find the first derivative, f prime of x. We call them as first derivative. Now this will give me 3x squared. I hope by now you are familiar with the rules of differentiation. So x cubed will give me 3x squared. Negative 6x squared will give me negative 12x. And this is negative 36. So this is my first derivative of the function. Now you can see here, this is a function. This is a cubic function, and this first derivative is a quadratic function. So now I consider this as a function, so I can derive again, and that is called a second derivative. So I second f double prime of, I put 2 prime f double prime of x. dy over dx is my first derivative, and I also write d square y over dx square for the second derivative, right? So this is f prime of x and f double prime of x, and what I derive from here, so this is my function now, and I derive from here, that is, it will be 6x minus 12. This is how I find the second derivative of a function. So I repeat once again here, my first derivative is, I consider this f of x as a function, cubic function, can be any function. So my first derivative, I get another function. Now if it is a function, then again I can derive again. I can continue like this, as third derivative, fourth derivative, fifth derivative, it goes on like that. But we are learning only up to second derivative. So this is my second derivative. I get here 6x minus 12, second derivative of the function x cubed minus 6x squared minus 36x plus 2. This is the second derivative. Now what relevance we have on the second derivative? Now why we are interested in second derivative? We will see now. You can see this is a graph, some cubic graph. Okay, some cubic graph. Okay. And now in this cubic graph, you can see this is a part of a parabola, right? You can see it's a part of a parabola. And you can see this is actually a concave down parabola, which we call them as frown. And you can see after some time, it now becomes a smile. So I changed my mood from frown, all right? And I start smiling. This is concave down. Now this is concave up, right? So that's how I think it has both. The cubic graph contains both frown and smile. So I like it. Now you can see this point. What interesting point here is the fact that this point is concave down and it becoming concave up. Now the point where the concave down changes to concave up, right? So we're interested in that particular point, and that particular point we call them as change of concavity. What we call as change of concavity. Point of change of concavity, right? So this is what we call change of concavity. So a concave up is changing to concave down, or concave down is changing to concave up. In this case, it's concave down changing to concave up. In the negative graph, it will be concave up and then changing to concave down graph. So that is the simple terms to understand the change of concavity. So point of concavity, we call them as alternate name, we also call them as point of inflection. So there are two names here, in fact 3, but I'll discuss that later. Third one, it is what? The point of inflection or change of concavity, this point, right? So point of inflection or change of concavity. So this is now second derivative. Second derivative, f prime of second derivative is equal to 0 at the point of inflection. So that is the relevance now. So at change of concavity, f double prime second derivative is equals f double prime of x is equal to 0. Second derivative is equal to 0. And that is called point of inflection. X coordinate is called the point of inflection. Or you can find the y coordinate, you substitute the original function, and then you find the y coordinate as well. So let's understand this now. This point, this we call them as x-intercept, right? X-intercepts. And x-intercepts are f of x is equal to 0. So when f of x is equal to 0, I call them as intercepts. Right? Now I have turning points, right? I have turning points. At turning points, I have f prime of x is equal to 0. These are called the turning points or stationary points. Turning points or stationary point. Right? So it is f prime of x is equal to 0. So, and then the change of concavity is f double prime of x is equal to 0. So I repeat here now, this is my cubic graph here. Let's make some cubic graph. So in a cubic graph, you may find a x-intercept. How will you find x-intercepts? f of x is equal to 0. How you find turning points? f prime of x is equal to 0. How you find change of point of inflection? Is f double prime of x is equal to 0. So these are the important points apart from the y-intercepts. Important points of a cubic graph. F of x is equal to 0 intercepts, f prime of x is equal to turning points, point of inflection, f double prime of x is equal to 0. This is called the change of concavity. For this is we want to find the change of concavity for some of the graphs. All graphs we can have the change of concavity, but in some graphs it becomes very important. Now let's take this question here now. Sketch the graph 4x cubed minus 6x squared plus 3x plus 62, showing the intercepts with the axis and stationary points. We can straight away write the y-intercept as 0, 62. This 62 constant term is my y-intercept. Now to find the x-intercept, what I do is I use my calculator. I have typed the function in my calculator 4x cubed minus 6x squared plus 3x plus 62. Then I press equal to, and I start from negative 5, and I end also at 5 with a step of 1. Okay, and then I press equal to. You can scroll down and see which one is equal to. You can see is when x is equal to negative 2, I got equal to 0. Now to find the x-intercepts, I got f of 2, now f of negative 2 is equal to 0. Therefore, I got ex plus 2 is a factor. So that I got one of the factors. Therefore, now I can write 4x cubed minus 6x squared plus 3x plus 62 is equal to x plus 2 times is some quadratic factor. So what are going to be my quadratic factor? Now the second factor is a quadratic factor. So I know it's ax squared plus bx plus c. So I look at the first a is going to be 4 times x squared, because when I multiply 4 times x squared, x will give me 4x cubed. That is why I am doing that. Then the last term is going to be some, we do not know what's the middle term, we write bx, and the last term 2 times 31 should give me 62, right? So you can see this 2 times 61 will give me 62. 2 times 31 will give me 62. So my this is my quadratic factor. This is my quadratic factor. So I have to solve for b. How do I do that? I expand on b terms only. That is, that involve terms involving b. So which are the terms that involves b here? So I can see b times bx squared. That will give me b times x squared. So next term x squared is 2 times 4x squared. So that will give me 8x squared. No other term will give me x squared. And then I compare with the original one. So that is, with the original one is negative 6x squared. So I'll write as negative 6x squared. And then now I solve for b. So b plus 8 is equal to negative. So I drop the x squared. Therefore, b is equal to negative 14. So what are my factors? My factors are 4x cubed minus 6x squared plus 3x plus 62 is equal to x plus 2 times 4x squared. Let me write neatly. 4x squared minus 14x plus 31. Now I have to factorize this 4x squared minus 14x plus 31, or I can find it solve a quadratic equation. Yes, you see, I have reduced this size, so I like this technology where I can manipulate things. So this is my where I've stopped here. I factorize it. Now I have to find the x-intercept. I mean f of x is equal to 0. That means x plus 2 is equal x plus 2 times 4x squared minus 14x plus 31 is equal to 0. I got x is equal to negative 2 or 4x squared minus 14x plus 31 is equal to 0. So I can use my quadratic equation to solve for x. Now I have to solve the quadratic one by using quadratic equation. So I can say x is equal to minus of, I use my formula here, square root of minus 14 squared minus b square minus 4ac, so it's 4 times 31 the whole divided by 2 times 4. Now I use my quadratic formula to find the solutions of the quadratic equation. So I typed it in my calculator. There you can see it is negative of negative 14 plus negative 14 squared minus 4 times 14 times 31 times 2 times 4. So my formula is correct, and I press and I get a max error. So I want to check if the roots really does not exist. So what I'll do, I'll try to type 14 squared b square minus 4ac minus 4 times 4 times 31. So in fact it has to be negative 14. So let me make it negative 14. Open the brackets, negative, and I close the brackets at here. So it's negative 14 squared minus 4 times negative. So 4 times positive 31. So you get a negative 300. So b square minus 4 is negative. That means the roots are unreal. So I can now write here no real roots. And that means the only root, therefore only root is, so only x-intercept is x is equal to, so only x-intercept is negative 2, 0. That's my only x-intercept. We want only x-intercept and y-intercept. So I remove those that I don't want. So I got only x-intercept. So we don't want this, just to make a clear space, to get more space on what we are doing. I'm removing them. I have neatly organized my work here now, my y-intercept and my x-intercept. Now my next term is to find the turning points. So to find the turning points, what will I do? I'll first find f prime of x. So what is my f prime of x? Is going to be 12x squared minus 12x plus 3. I hope that you are now comfortable. 4 times 3 will give me 12 and reduce the power of x cubed by 1, that is x squared. 6 times 12 will give me 12. 6 times 2 will give me 12 and reduce the power of x squared, it becomes 1. And this becomes 3. That is my first derivative. Now at turning points, at stationary points, I have f prime of x is equal to 0. That is 12x squared minus 12x plus 3 is equal to 0 at turning points. So again, I use my calculator to find the x-intercepts or the x-coordinates of the turning point. So I get x is equal to half or x is equal to, I got both the same values. Interesting. I got the same values for the turning points. So now I have to find the y-coordinate. So I type in y-coordinate, means what I'll do, I'll type f of the original function. I type this 1 over to the original function. So f of 2, that will be equal to 1 or 4 times 1 over 2 cube minus 6 times 1 over 2 squared plus 3 times 1 over 2 plus 62. Now I type it in my calculator and I got 125 over 2. So I can write as 62,5. 125 over 2 is 62,5. So what are my turning points? My turning points are half, 1 over 2 and 62,5. So it is half, not 3. Let me write very neatly. So it's 1 over 2, 62,5. So I got this answer here. These are my turning points. You see my turning points are equal. That is interesting now. I have neatly arranged them, all the information that I have, all the calculations that I have made so far. Now, when the turning points are equal, we must find the point of inflection. We can always find the point of inflection, but when sketching the graph, when the turning points are equal, we have to find the point of inflection. Therefore, that means to find the point of inflection, f double prime of x, I have to find f double prime. So I know f prime of x is equal to 12x squared minus 12x. So now you see what I'll do, I'll find from derivative from here. So just derivative from here, derivative from here, that is 12 times 2, 24, 24x minus 12. So at a point of inflection, POI, point of inflection, f double prime of second derivative is equal to 0. F double prime of x is equal to 0. That is 24x minus 12 is equal to 0. So 24x is equal to 12. X is equal to 1 over 2. Hey, look, it's very interesting. My turning points are equal and the point of inflection has the same point. So that is it. So when the turning points are equal, that will be the point of inflection. Remember, in the previous one, we said when the turning x-intercepts are equal, that will become the turning point. When the turning points are equal, that will become the point of inflection. So my point of inflection here is again f of half, which is again we already found out, which is 62,5. So I got the point of inflection. So now we got all the points. We got x-intercepts, we got the turning point, and we found the turning points are equal. Therefore, we got the point of inflection as well. Now I am going to rearrange them. Yeah, now let's try to sketch this graph. I have neatly organized here my important points here. So first is 0, 62. So we don't see 1, 2, 3. We don't write 1, 2, 3, 4, 5, 6. We don't do that. So we just put some point here, 62, some random point, and I'm put this point. This is 62 here, right? 62. And then negative 2, 0. So it's negative 2, 0. And then we have half, 0, 5, 62,5. You see, half is somewhere here, just above this one. So this is going to be my turning point as well as my point of inflection. You can see they are equal. Right? So half is same as 0, 5. Now you can see they are equal. That is my graph. So when the turning points are equal and when we have a point of inflection, so it's interesting to see how the graph will look like. So remember, we don't have a turning point and we have only one x-intercept. It's a positive graph, 4x. So I start from left to bottom. So I start somewhere here from the left bottom, and I go like this, and I go like this, and I touch the x, I touch the y-intercept, and you can see there's a small like, so it should be concave down, just like concave down, and then again as if concave up. So this is going to be my graph, f of x. So now and I mark and I plot this point here. My point here is 0, right? Is half 62,5 or 0,5. So this is my point of inflection, and this is my y-intercept. This is my x-intercept. So that's why I'm done with my graph.